In unimodal distribution, only one value repeating most frequently comparing to other value, only one numbers are repeating. Number, whichever the set of data is given, which is not at all repeating, means there is no mode at all. So the L stand for lower limit of the model class. In this lower limit, how much you are getting? 40. Okay, the numbers of data, whatever it is repeat, you need to observe very carefully how many numbers are repeating. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in Commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. So we are in the Unit 1, Section 6, third semester BCom, Statistical Data and Descriptive Statistical. Today my agenda is mode meaning, characteristic of mode, mode discrete data format, mode continuous data format, and few problems related to mode. Moving forward. So what exactly the mode? The set of data either they can give in the horizontal or vertical. For example, the data which is given in the question, you need to identify which number is occurring again and again or repeating same number of times. Okay, so this is looking like vertical and this one is looking like horizontal. The data whatever they given, for example, you are taking 5, 7, 2, okay, or 5, 7, 2. Okay, now it is looking like vertical and horizontal. Which number is repeating 2 times? So this number is repeating 2 times. So that's what in the unimodal only one numbers are repeated 2 times. So that's what you can identify. This 5 is coming under mode. Now, even the same thing, they can give in the horizontal format or vertical data set, whatever it may be. The data is the most frequently occurring value in the data set. Now it is data set. Now which is, there is no frequencies given, observations are not given. So, which is under discrete data. Directly you can say which is an ungrouped data, because group is there means frequency obviously you are able to identify. In addition to these 3 important measure of central tendency, what and all you studied in the previous session, for example mean, arithmetic mean, median. Okay, now we are in the mode. So another measure is also defined. The mode is the value and category that occur most of the data set. The number of data, how many times are repeating again and again it is coming, right? That's what, which is a, now you can identify in this set of data. Now 5 is repeating 2 times, so we can say the 5 is a mode. If all the elements in the data set have the same frequency of occurrence, okay, then the distribution does not have. For example, 5 is 2 times, 7 is 2 times, 2 is 2 times. Now all are equally appearance. So if one numbers are increase compared to other 2 numbers. Now in the mode we are majorly classified into unimode. Unimode means only one numbers are repeating more number of times. Okay, bimode means what? There are 2 numbers are equally repeating. Okay, the same number of times they are repeating. For example, 5 is repeating 2 times, 7 is repeating 2 times, then it is a bimodal because 2 numbers we are able to identify. And 3 model or multimodal. 3 model means 3 numbers are repeating same number of times. Okay, now for example 5 is repeating 2 times, 7 is repeating through 2 times, 2 is repeating 2 times. Now it is a 3 model by. In unimodal distribution, only one value repeating most frequently comparing to other value, only one numbers are repeating. In this case 5 is repeating only one numbers. And bimodal has 2 elements have been highest frequency. For example, here bimodal. So when I am taking 5, 7, 2, now the 2 numbers, 5 is repeating 2 times, 7 is repeating 2 times. So it is looking like bimodal. Now like that there is a unimodal, bimodal and 3 model. 3 model means 3 numbers. Okay, trimodal you can say, or multimodal means multiple numbers are repeating same times. Okay, moving forward. Of course, the characteristic of the mode. Okay, even the arithmetic mean also you studied the characters, even the median also having a characters, even how mode also, of course the mode is having a characteristic. Mode is the easiest average to determine. It is used when the most typical value is required as a central value. Now in this set of data, vertical format or horizontal data, if you want to identify one specific value called central value, now you are identifying which number is repeating, okay, based on the types of mode. The mode can be found in the nominal data set. Nominal data set. This nominal data, the types of data or classification of data I have covered in the section of 1. Okay, you have to refer once again. So the nominal mode need not to be a unique measure. Okay, a distribution can have more than one mode or no mode at all, but more than one mode. Now for example, in the previous slide 5 is 2 times, okay, and if you try to take one more data set, 5 is 2 times, 7 is 2 times, okay. So bimodal or unimodal or 3 model, or you are able to identify, or number, whichever the set of data is given which is not at all repeating, means there is no mode at all. Okay, moving forward. Now you need to familiar when you try to solve the problem as a statistician student, you need to identify what kind of data is given, how it is looking, either it is a discrete data, either it is a discrete data, group data or ungrouped data or continuous data. Now you have to identify. Now here under discrete data, we are classified into majorly two classification. Ungrouped data, we are not able to see the frequency, and group data, we are able to see the frequency. Okay, in the ungrouped data discrete method, directly which number from the X series or set of data, whatever it is given, which number is repeating. So here 40, 20, 30, 40. Now 40 is 2 times repeated. Now your mode is equal to, mode is always symbolically representing Z. Z is equal to 40. You can directly answer. Now if you try to go for discrete data, group data, so under group data you are able to identify, you are able to see the frequency. Now 40, 20, 30, 40. 40, 20, 30, 40. Now from the frequency, now you are giving importance for group data, frequency you are giving important. The step 1, identify the highest frequency. From the frequency you are identified, highest frequency is a 4. Okay, now second step, read the corresponding X value, just opposite. Okay, go back, read the corresponding value. Now mode is, you are able to identify mode from the X series 20. 20 is a mode. Okay, moving forward. Now there are two sets. First, discrete method. Now it is a continuous data. In the continuous data, whenever you are trying to solve the problem, of course you have to depend on the exclusive data only. In case if it is given inclusive data, now you have to convert for the exclusive data. Now how you can identify which is looking like inclusive data or exclusive data? Inclusive data or exclusive data, there is a very simple difference here. The first class lower limit, this side is the lower limit and upper limit. Okay, upper limit, when the first class upper limit will carry for the second class as a lower limit, no doubt it is looking like exclusive data. Okay, so if you try to take, for example, one more example for inclusive data, for example 10 to 19 is given, next one 20 to 29 is given. In this case you are able to identify this is looking like inclusive data, because the first class upper limit will not carry for the second class lower limit. That's what we can say, it is an inclusive data. In this case we need to convert. Okay, how we are converting the inclusive data into exclusive data? So lower limit to subtract 0.5, upper limit add 0.5. Okay, now in this case you can find out, see here same thing, 0.5 subtract, 0.5 add. Now 9.5 and 19.5. Now see 20 minus 0.5, 20 minus 0.5, 19.5. Now see from the first class, which is the upper limit is 19.5, will carry for the lower limit for 19.5. So now it is a converted. Clear? The step 1, identify the highest frequency in the continuous data. Whenever they are given continuous series data, always you need to assume which is a group data only. Okay, when the group data means you are able to identify there is a frequency. In case in the question if they are asking less than cumulative frequency or more than cumulative frequency, of course you need to convert into frequency. This is directly in the problem, it is given one example, which is looking like a continuous data, frequency is given, from the frequency. Now you need to, step 1, identify the first frequency, call it as F1. Okay, highest from the frequency we are identified, 12 is highest frequency. Now call it as F1. F1 is a highest frequency, maximum frequency value. Now second one, read the corresponding class. Read the corresponding class. Though this complete class will be called as a mode class. Mode class. Okay. Now mode class, that is the class where mode is lying. Now the mode is lying in this specific class. Now third step, apply the formula. Z is equal to L plus F1 minus F0 divided by F1 minus F0 plus F1 minus F2, okay, close the bracket, into C means width. See, from highest frequency whatever you are observing, you are call it as F1, here F1, okay, and pre-class you have to call it as a F0, and post class from the highest frequency F2, which is a post class. Pre-class means previous one, post class means next one. Okay, now see, Z is a symbolically mode. The formula whatever it is given, according to formula we need to simplify, that's it. So the L stand for lower limit of the model class. In this lower limit, how much you are getting? 40. Okay, and F1 is a highest frequency. Highest frequency how much? 12. Okay, from the class interval, highest frequency how much you are getting? 12. Clear? So 12 you are writing, and F0 means previous one. Previous one how much you are getting? 7. And same thing, frequency 1, the same, whatever the numerator is coming, same thing. And one more thing we are adding here, F1 is continue from all the formula. Denominator will start from the F1, numerator also start from F1, ending with the F0 first, next F0, next minus F2, into C is a equal distance, width of the class. Now in this class, width how much? Equal distance we are getting 10, 10, 10. Okay, so I hope you understood this one. And here we are trying to solve the problem based on the discrete data, ungrouped data, because the frequency is not given. So have a look on here. Here the age of 13 job applicant is given. Now you need to consider this age is called for X series. From this X series, which number is repeating maximum time? So here 16, 17, 18, 19, 20, 25, 25, 25, 26, 28, 30, 34, 35. Now highest number, the 25 is repeating 3 times. The 25 is repeating how many times? 3 times. Now it is in the discrete data, ungrouped data. Now we call it as the mode is equal to X is equal to 25, because the 25 is repeated 3 times, maximum number time repeated compared to other numbers. Moving forward. So here one more example for under discrete data, ungrouped data. Find the mode from the given data. Now 10, 12, 34, 34, 45, 23, 42, 36, 34, 22, 20, 27, 33. Now which number is repeating more times? Which number is repeating more time? Now see, 34 is repeating 1, 2, 3. Okay, 3 times 34 is repeating, maximum time it is repeating. Okay, so because 34 is repeating 3 times, now mode is equal to 34 in the discrete ungrouped data. Again one more example, find the mode from the numerical data set. 109, 112, 109, okay, 110, 109, okay, this set of data whatever it is given. Now you can see, you can observe here, 109 how many times? 1, 2, 3, 4, 5 times. 109 is 5 times is repeated. Okay, 109 is 5 times repeated. Now again one more number is here, 104, 1, 2, 3, 4, 5. So here 104 also, which is repeating 5 times. Okay, so in this case the mode is other number. If you try to compare, which number is not at all repeated 1 time also. So in this case the 2 numbers are repeating same time. So as in this problem we are not able to identify or judge mode is 109 or 104. So in this case we call it as a hill define. Okay, there is no mode in the problem because equal distance. Now you are easily identify which classification of mode, which is a bimodal. Okay, the 2 numbers are repeating 2 same times. The total number of elements in the out of 15. Okay, here out of 15, 109 is 5 times, 104 104 is 5 times. Okay, so all among the 15 data element, the value of 104 5 times, 109 5 times, both occurring 5 times, which is hence the mode of the data set. This problem is bimodal, identify, because two numbers are repeating equal times. So mode is ill-defined. You are not able to identify mode here. In this, again, there is one more problem here. The following table show the sports activity of 1977 students. Okay, the tabular format, whatever it is given. First one, the sports: tennis, gymnastic, basketball, baseball, and athletic, none. And even the frequency is given. Now we are call it as this sports is called X series. Okay, so X series means always in the graph we are going for X series. Here it is sports. X series denote for sports, Y series denote for frequency, or you can call it as number of students. Here the tennis is 368, the tennis is 368, gymnastic 125, basketball 452, and baseball is 380, and Atlantic 275, none 377. Now this frequency, again you need to identify, this problem is looking like discrete data and group data, discrete data, group data. Okay, so from the frequency, highest one, this one 452. Okay, now each and every sports we are call it as a X series. Okay, now in the tennis X series value, so in the tennis 368, we are just using a bar diagram to just identify the which is the highest. Now second one, gymnastic 125, gymnastic bar diagram 125. Okay, and basketball 458. So 458, which is the bar diagram is 458. Okay, 380 is a baseball, 380 is a baseball. Okay, and next one, Atlantic 275, bar diagram Atlantic 275. Last one is none 377. So none is a 377. Now if you try to visualize, so which bar will be highest peak? Okay, which is going for highest around the basketball is a mode. Okay, so here it is very clear to understand. Now seeing the graph only we are able to identify the basket player, the student of those who are playing basketball 452. From the given data, for group data, the class with the highest frequency is called for mode class. The category with the longest column means basketball is the longest column. In the bar graph represent the mode of the data set. Now in this data there are 6 sports are given. Okay, the basketball has the highest frequency of 452. That's what we call it as a mode is a basketball. So hence the basketball is the mode of the sports activity. I hope you understood this diagram. Moving forward. So here one more question. The marks scored 12, 15, 20, 10, 30, 20, 10, 20. Okay, now 20 how many times is repeated? 1 time, 2 time, 3 time. 10 how many times is repeated? 1 time, 2 time. 30 is not repeated. Now it is directly we can call it as a mode is 20 is repeating 3 times. So we can directly say the mode is 20. Now second question, height in centimeter. 170.3, 160.4, 171.3, 159.4, 170.3, 165.1, 160.4. So now here equally 160.4 2 times, 170.3 2 times, equally repeated 2 times equally. Now which is this problem is looking like a bimodal. Okay, so in this case also we are not able to decide. There is a mode ill-defined. Ill-defined means there is a equal distance. Ill-defined problem. In this problem Z cannot be both 160.4 and 170.4, which cannot be a mode. So it is a not uniquely defined. Here Z is a ill defined because 2 by model is given means which one we are not able to decide here. Okay. So when we have 2 more, the distribution is called you should familiar the by model distribution. 2 numbers are repeating 2 times equally. Similarly, mode can be 3 model or multi-model distribution. In this case also called as ill defined. If the, for example, this number also repeating one more time, this number 171 is repeating, okay, compared to this here 2 numbers are repeating 2 times. Now if you are taking one more example, 171.3 are repeating one more time, okay, then also it is a 3 model. Okay, so the numbers of data whatever it is repeat, you need to observe very carefully how many numbers are repeating. Highest repetitions will be call it as mode. And there is one more problem for your just understanding, which is also looking like a discrete data, ungrouped data, 11, 13, 7, 10, 15, 3, 12, 11, 4, 14. So except 11, there is no other numbers are not at all repeated. So we can call it as the mode is 11 is repeating 2 times. So directly Z is equal to mode is 11. Moving forward. And this problem, if you are seeing this problem, you can understand under discrete data, it is looking like a group data because the frequency is given, number of persons means no doubt it is a frequency. So here the size of shoe and number of persons are given. So now we are able to identify, first step, identify the frequency which is highest frequency. From the highest frequency, highest frequency is a 20. Now seeing itself, you can identify the mode is 7.5 inches. The shoe size is there for 7 inches. See, in this highest frequency 20, now it is directly given frequency. If it is given cumulative frequency or more than cumulative frequency, again we need to do for conversion. Okay, in this case we are solving because the frequency problem is given here. So the highest frequency once you identify, now correspondingly the shoe size will be 7.5. Now Z is equal to 7.5 inches. Next one more question. Calculate mode from the following data regarding most common wages of the set of employee. Most common. Now there are, for example, here first set of first wages, second wages, third wages, fourth wages, fifth wages. 5 wages slab is given. Now which wages is current repeating again and again, you need to identify. Okay, so the number of workers. So seeing the problem itself, we can identify which is looking like a cumulative frequency. Cumulative frequency means now it is increasing order. Now in this case frequency is missing. Now you need to convert. Now in the wages whatever it is given, as it is you are writing in the vertical format. Okay, now whatever the given information which is nothing but cumulative frequency is given. Okay, with the help of cumulative frequency we need to convert for frequency. The first cumulative frequency I am writing as it is 1. Okay, the second frequency how I am getting 4 minus 1 I am getting 3. Okay, next frequency 7 I am getting 11 minus 4 I am getting 7. 19 minus 11 if you subtract I am getting 8. 23 minus 19 if you subtract I am getting 4. Okay, the highest cumulative frequency value is 23. Now if you take the total of frequency which is equivalent to highest frequency whatever it is there in the cumulative frequency, now you can identify. So step 1, identify the highest frequency. From the highest frequency means this one. So now the corresponding value 6000. Okay, from the frequency we are reading corresponding value from the X series 6000. So in this case the highest frequency is 8. Okay, so the corresponding wages is 6000. Now Z is equal to 6000. Moving forward, and one more example, one more questions related to the discrete data, group data. Now this data is continuous data. Okay, now continuous data, lower limit and upper limit is given, but this continuous data looking like inclusive data because the first class whatever it is given which is the first class of upper limit is 19, which is not carry for the second class as a lower limit. That's what I can say. You can understand this is looking like inclusive data. In this case, I just want to convert into exclusive data. So it is a simple procedure. Lower limit minus 0.5 and upper limit plus 0.5. If you do this process, okay, this one, then easily we are able to get the exclusive data. Now from the first class of lower limit, how much? 15 minus 0.5, 14.5, and second class, first class of upper limit 19 plus 0.5 means 19.5. okay, if you take example for next class, 20 minus 0.5, 19.5, upper limit 24.5, 24 plus 0.5, if you add 24. Now in this case, which is always looking, now it is looking like a exclusive data. From the first class upper limit 19.5, whatever it is there, which is carry for the second class as a lower limit, then it is looking like exclusive data. When you are trying to solve this problem, which is looking like continuous data, the step one you need to, okay, coming slide you are getting in clarity. So the frequency, whatever it is given in the question, now you need to identify, find maximum frequency, call it as F1, call it as F1. So previous frequency is F0, next frequency value F2. okay, so moving forward, see, now the highest frequency, the formula one more time I am writing here just for understanding. Lower limit plus F1 means highest frequency minus F0 divided by F1 minus F0 plus F1 minus F2. okay, now close the bracket, into C equal. Now in this formula, highest frequency is 10. Now you call it as, this is called model class, model class. okay, from this only we are getting the majority of the data, whatever it is related to your formula. So in case of F1 we are writing 10, F0 we are writing 7, okay, F2 we are writing 8. The lower limit L is for 24.5. okay, coming slide you will get more clarity. So now you identify in the highest frequency, F1 is highest frequency, the complete class is a model class. So here according to formula, L is a lower limit 24.5. The 24 point, the formula basis L plus I am writing 24.5, and F1 plus I just note here F1 is highest frequency 10. okay, and F0 plus the pre-mode, F0 plus pre-mode 7. okay, I am writing 7. okay, the same thing is the formula is having a F1 minus F0, the same thing is going for the denominator. So and F1 plus same thing, the highest frequency is a 10. okay, post frequency means 8. okay, now F2 plus I am writing 8. So into C plus I am writing into C plus, because the problem having a equal distance for 5 width. okay, now C plus I am writing 5. okay, now if you try to simplify, 10 minus 7 3 and 10 minus 8 2, and the equal distance is C. Here is the maximum frequency. Substituting this value of the above formula, again the same procedure, one by one the steps you have to simplify. So the first one I just want to calculate this part. okay, the 24.5 as it is I am writing, so plus sign, and since 10 minus 7 you are getting 3, and 10 minus denominator 10 minus 7 3, and 10 minus 2 means 2. okay, now you multiply with the C, equal distance. Again one more step I am going, 24.5 as it is, 3 numerator, denominator if you add 5, okay, into 5. Now 3 into 5 directly 15. okay, now 24.5 as it is I am writing, 3 into 5 15, the denominator whatever it is there I am writing. Now after simplifying I am getting 3. now your mode is a 27.4. now mode is how much? 27.4. 5. So here one more problem is find mode from the following data graphically. In the previous session we did finding the mode with the help of graph. So here also mode also we are able to identify with this in this data whatever it is. Graphically also we can identify. Again we are verifying the new numbers, what exactly how much we are getting with the help of graph. Even applying the formula how much we are getting, we are just going for verifying. So here the x series whatever it is given class interval, so x series will be class interval and y series will be frequency. In the problem it is given the class interval and frequency is given. Now when it is looking like continuous data, exclusive data, because the exclusive data I told you different. The first class upper limit will carry for the second class for lower limit. Now it is looking like exclusive data, we don't want to convert for further. Okay, so from the frequency whatever it is given, now from the frequency, now highest frequency is coming 497. Okay, so here the 407. Now according to graph, y axis 1 centimeter denote for 5 units and x axis x axis 1 centimeter denote for 5 units. Okay, now according to each and every class we need to mark. Okay, now first class will start from 0 and upper limit is 50, lower limit 0, upper limit 50, the value is 41. I am just marking here 41. Okay, one bar diagram I am using. Okay, next class 50, lower limit 50, upper limit 100, lower limit 50, upper limit 100, the value is 171. 171 one marking. Okay, here I just want to draw one more bar. Again next class, third class 100, lower limit, upper limit 150, lower limit is 100, upper limit 150. Okay, the value is 286. 286 one line bar diagram. And next class lower limit 150, upper limit 200, lower limit of 150, upper limit 200, the value is 496. 496 I just want to draw the one bar. Okay, and next one 200, lower limit, upper limit 250, 200 lower limit, upper limit is 250, the value is 382. 300 opposite to 382 one more bar I want to draw. Okay, and 250 to 300, 250 lower limit, upper limit is 300, the value is 211. 211 I'm just marking one bar. Okay, again now last class we say lower limit is 300, upper limit is 350, lower limit 300, upper limit 350, the value is 87. 87 opposite one bar. Okay, now so in this bar diagram, which bar is showing highest frequency? This bar is the highest frequency, we call it as F1. The highest frequency, once you are identify the highest frequency, now you need to with the help of a pre-class and post-class. Pre-class, this is a pre-class and post-class. Okay, this is post-class. Pre-class, post-class. From the pre-class, upper limit to highest frequency, the highest frequency which is coming under 497 bar I am selecting. So using previous class mode upper limit, I just want to extended the perpendicular line which is touching for the highest frequency bar. Okay, and the same thing, the first class now I will consider lower limit. From lower limit which is touching here, I need to extend the perpendicular line to the highest frequency class 497. Now lower limit from the post class, upper limit from the previous class. Okay, where it is intersecting, this is called mode. Okay, now this is looking like now we with the help of graph here identify the mode. Again anyway we are trying to verify with the help of formula. So from the highest, the step one. Okay, in the previous slide, the mode slide, you just have a look here. In the continuous data, the first one identify the highest frequency, second one read the corresponding class. Okay, that is modal class. Okay, third step is apply the formula. The same step we are following to solve this problem. Even the previous problem also we did. Okay, now from the data set which is written in the horizontal format, now highest frequency which is called for F1. Okay, this is nothing but highest frequency is a modal class. Okay, so previous one F0, post one, next to F2. Okay, now with the help of formula we need to simplify. So first lower limit here 150. Okay, whatever the given the value I am writing. So according to formula, L is given, L is identified, lower limit is 150. F1 highest frequency, F1 is equal to 497. Okay, F0 means previous one, F0 287. Okay, next F2 means post, next. Okay, F2 value 382. Okay, now C plus equal class, each and every class having a 50-50 difference. So C is denoting 50. Now according to formula, whatever it is there, I have written here. Okay, now we need to simplify one by one. Okay, the first L place I am writing 150. F1 place I have already specified here 497. F0 plus I have specified here 287. Okay, and the same thing which is there in the numerator as well as denominator, because formula is having F1 minus F0, the same plus I am writing same thing, the plus sign. F1 plus again 497. Okay, F2 plus I am writing 387 because which is in the next class. Okay, 382. C plus I am writing 50. If you try to simplify one by one, okay, so first 150 and 497 minus 287 subtract means you are getting 210. Divided by first one, you need to simplify this one, you are getting 210. Second one, if you simplify subtract, then you are getting 115. Okay, so now one more step I am extending here. The same 150 I am writing as it is. Now here 210 into 50, if you multiply 10,500, okay, denominator if you add together we are getting 325. Finally if you substitute simplify it, then we are getting a mode is 182.3. now see 182.3. now here it is the mode is Z is equal to 182.3. we are able to identify, we are getting the same answer. Keep on watch for next section. Thank you.